value problem can be written as or called as BVP, boundary value problem. So second order differential equation is the linear nth order differential equation. If we select n equals to 2, then it becomes a2 of x into d2y by dx square plus a1 of x into dy by dx plus a naught of x into y equals to g of x, subject to the initial conditions. Now the only difference between initial value problem and boundary value problem is these conditions. Initial value has all the initial points like x naught or x1 or y dash of x naught, y double dash of x naught. So it's all related to the initial value or x at rest at the very start. But here the conditions are y of a equals to y naught, and there is another point, that is y of b equals to y1. So basically it is concerned with the endpoints. Like if we have an interval and if the starting point is a and the end point is b, so these two are endpoints or limit points, you can say, or you can say the boundary points. So a and b are the boundary points, and y has the value at when x is a is y naught, and when x is b, y has the value y1. So these are called boundary conditions, or I can say as, these are called boundary conditions. And if we have second order boundary condition, second order differential equation, then again the conditions should be one derivative less than this condition. Okay, so this is a boundary value problem. Now how the boundary value problem is solved, and what are the basic conditions for checking the solution of the boundary value problem exist or not. What we do, we just apply this boundary conditions onto the problem, and there are three types of solution in a boundary value problem. First is, it can be a unique solution, it can be several solutions, or it can be solution does not exist or there is no solution at all if it leads to the contradiction. So in the next example, or in the first example, we can say we will study how the boundary value problem is solved and how can we judge that whether the solution exists or not. So this is example number 1. This is example number 1, and the differential equation is y double dash plus 16 into y equals to 0, and it has solution given. So we have to check that whether its solution exists or not, if it is unique or not, and third is that if it has no solution or not. So it has the solution y equals to c1 cos of 4x plus c2 sine of 4x, subject to these boundary conditions. Now this is basically a 2-parameter family of solution, and that is, we can say this is a 2-parameter family of solution. One is cos 4x and the other one is sine 4x, and we have two boundary conditions. When x is 0, y is 0, and second one is when x is pi by 2, y is 0. So what we do, we apply both of these boundary conditions to check that whether this boundary value problem has no solution, several solution, or unique solution. All right. Okay, now apply in this y c1 cos 4x plus c2 sine 4x. Apply this condition, apply these values of x and y to check what is c1 and what is c2. So y is 0 in this. Y is 0, C1 cos of 4 into 0 plus C2 sine of 4 into 0. Okay, sine of 0 is equal to 0, so that means that this all factor becomes 0 and cos of 0 is 1, so C1 into 1 equals to 0. So C1 has value 0. It means that now your solution is reduced to C1 is 0 and C2 is sine 4x. Now your solution is reduced to one parameter family. So now we apply the second condition. Second condition is when x is pi by 2, y is 0. So we apply here in this. X is pi by 2, y is 0. So 0 equals to C2 sine 4 into pi by 2. And it becomes C2 sine of 2 pi. So that means either C2 is 0 or sine 2 pi is 0. So sine of 2 pi, that means 180 multiplied by 2 pi is 180 in, if you convert in degrees and radians. So 180 into 2 is sine 360, and sine 360, any integral multiple of this is equal to 0. So we know that integral multiple of all the 90s of sine is 0, so this condition is true, and C2 is not equal to 0. So that means that for any C2, for any choice of C2, this is equal to 0. So your solution here is reduced to C2 sine of 4x. So your two parameter family of solution is reduced to now one parameter family. And one parameter family is only regarding to sine 4x. So this is the boundary value problem. This solution is unique, and solution is not unique. For any choice means several solutions. So if you choose any C2, so you get several solutions, not a unique solution, sorry for that. So this is the solution of this. Okay, in the next example, we will check that whether the solution exists, unique, several, or no solution. So we start applying this boundary condition. First boundary condition is y double dash plus 16y, that means its solution is same here. Solution is y equals to C1 cos of 4x plus C2 sine of 4x, and we have conditions here, a little bit change condition, and that is it is in 0 in the first example, and here it is 1. So when we apply the first condition, that when x is 0, this condition, y is 0, it gives the same result as we have done before. So with this all the solution, solving this all condition, we get C1 equals to 0. So I'm not doing it again. Okay, we come to the second condition, which is a changed condition. So when x is pi by 2, y is what? 1. So we apply here, and your solution here is now C2 sine of 4x. So y is 1, C2 sine of 4 into pi by 2, C2 into sine of 2 pi equals to 1. We know that sine of 2 pi is always 0 and equals to 1. So in the left hand side it is 1, the right hand side it is 0. So these both sides are not equal, so that leads to a contradiction. So that means it has no solution at all. So in example 1 we have several solutions, in example 2 we have no solution at all. And if we have specific C1, C2, like if C1 is for the specific boundary condition, C1 is 1 and C2 becomes 2, then we can say that it is a unique solution, otherwise it is not. Okay, I hope that you understand the boundary value problem, and then we move further towards the linear dependence and independence to check the whether the solution or the functions are linearly independent or not.